Hello, in this tutorial I will teach you how to create tubes in CATIA FEA, how to create a basic frame, and after your work is done, how to analyze it with finite elements. I will also teach you the power copy feature that CATIA offers. The power copy feature is very important and is very useful if you want to copy a lot of steps and paste them at once. So let's say that you want to create a car chassis. You have to perform a lot of steps to create one tube, and then if you are not going to use the power copy feature, you have to do all your steps, repeat all your steps over and over again in order to create all the tubes. The power copy feature lets you copy all your steps at once, so actually you can copy the entire tube and paste it on your frame. That's very important, that's very useful. You wanna do it on wireframe and surface, so hit start, mechanical design, wireframe and surface design. The frame itself is not very important, the shape of the frame, you can do whatever frame you want. I recommend you to do the same frame that I'm doing here, because this way it will be easier for you to follow my steps. The way I will do it is I'm going to create points and then connect the points with lines. This is the easiest way, at least for me. That's the one I recommend you to do. My first point will be the 0, 0, 0. Actually, the planes are in my way. I will hide them. Right click, hide and show. Now that's easier for me to see. I'll create another point. This one will be 400. All my units are in inches. Another one 440. Another one will be 840, and on my last one I will use 880. There we go. I'm going to connect all the points with the line. Select line, line type, point to point, point number 1, point number 2. Okay, I just create the first line. I'll do it for all the points. There we go. Now what you want to do is to create the first tube. You're going to use sweep. Profile type will be circle. Subtype center and radius. The radius that we are going to use will be 0.05 inches. That's a good number. Just select the line that you want. Preview. That's okay. Select OK. We have the first tube. As you can see, this is a hollow tube. You can see through it. So this is a tube that will stay in the end of the frame. So basically, it will stay open in the back. And right over here, it will have one intersection. If you think about it, this tube will be the exactly same tube that will be here in the other end of the frame. But those tubes will be different from the tubes in the middle, because the tubes in the middle will have two intersections. So basically, we are going to create this tube, copy with the power copy feature, paste it here in this other end. Then we will create the tube in the middle with two intersections, copy it, and paste over this line. The way we are going to do the intersections will be creating a sphere at the end of the tube, and the sphere will connect the tube for us. So select sphere. Sphere limitations, you have to select create the whole sphere. Center radius will be the same radius of the tube, of course, 0.05 inches. Now over here in center, this is very important. You have to right click it, create endpoint. Now you want to select this point over here. You cannot actually select the point. You have to select because there are two lines intersecting the same point. So you want to move your cursor in this line, in the tube that you are working with, and the software will automatically select the point for you. Let's click OK. It created a sphere. The problem about this method is that we just created a sphere inside our tube. That doesn't work for us. We have to split the sphere in half and remove the side inside the tube. We will have to create a plane. Plane type will be normal to curve. This will be the curve. Point, again, right click, create endpoint. Select the line. It will automatically select the point for you. Hit OK. This plane is exactly in the middle of our sphere. It's very important that you always select the create the endpoint, because the copy feature is going to copy all your steps. So let's say you do not create the endpoint, you just select this point. When you're going to use the copy feature, let's say to paste this tube in this line, the software will select this point over here instead of one of the points in the edges, which is not what you want. So that's why you have to always create the endpoint so the software can understand what you want. Now we are going to split this sphere. We can go over here, split. We can select directly from the tree. It's easier. We want to element to cut. We want to cut the sphere. Cutting elements will be the plane. Okay. You cannot see actually what has been done because it's inside the tube, but the other half of the sphere is now gone. Now we have a half sphere and a tube which are not connected. We have to connect them. We are going to do it by using this feature over here called join. We're going to join the sweep and the split. Okay, there we go. Now we have a join with the sphere and the tube. That's good for us. This tube is done. We can copy and paste it over here on top of this line. Now it's time to use the copy feature. You can click on Insert, Advanced Replication Tools, copy creation. We want to copy the join. Now input of components. The software is asking us to select one split and one sweep in order to create the join. That's too much. You can just left click. Alright, that's good enough because now we only have to select one line and the software will paste all the other steps. That's good enough. Okay. Now here in the tree, the copy appears. What you want to do is right click the copy, go to copy object, instantiate. There we go. Now we have to select which line we want to paste the join. We want on this line over here. The green arrow indicates the direction. Keep in mind that this is not a symmetric tube, which means that the sphere has to be on top of this point. It's right now in the opposite direction, so let's click in the arrow, preview. We can see that the sphere is in the right place. Hit OK. Now it's open in the back and the sphere is in the right place. We can move on now and create the next tube. Again, sweep, profile type circle, radius the same, center curve this one, preview. Okay, okay. we will have to create another sphere, but this time we have to do it twice, one in this end and another sphere in the other end of the tube. The spheres will be one on top of the other, but after our work is done here, we are going to close the profiles, so that doesn't matter. The software will understand that we want just one sphere. Select sphere, again, full sphere, center, create endpoint, this will be the center. Okay, create another sphere, whole sphere, create endpoint. Okay, now again we have to split this sphere. We're going to create two planes. Plane type normal to curve. This is the curve. Create endpoint. This will be the plane. Okay. Now creating the second plane. This is the curve. Create endpoint. This is the plane. Okay. Now we have to split the sphere. Select the split. Elements to cut. It will be this sphere over here, which is sphere number 3. So sphere 3, and this plane, which is plane 3. Okay. Now we want to split the other side as well, which is this sphere here, sphere 4, and this plane over here, plane 4. Okay. Now we want to create a join with the two spheres and the sweep. Select join. This time the elements to join will be the sweep number 3, the split number 3, the split number 4. Okay, now we have a third join. We are going to copy this join with the paracopy feature. Here on Advanced Replication Tools, paracopy creation, we want to select the join number 3. Again, only one line, line 2, that's okay, hit OK. Here in the tree, another paracopy will appear, paracopy number 2. Right click, paracopy object, instantiate. This is the line that you want. The direction doesn't matter because this is symmetric. Preview. Okay. We have our frame almost done. We just have to close the surface so the software can understand that this will be only one sphere, and we don't want to left our tubes open here in the ends. We want to close it. It will still be hollow, only the ends will be closed. The way you want to do it is moving to part design. So select start, mechanical design, part design. Now we want to select the closed surface, which will be here inside the fixed surface, closed surface. We want first to close the join 1. So the join 1, okay. Close again the join number 2, okay. Now close the join number 3. And at last the join number 4. Now we have all the surface closed, so we don't need actually the joins anymore. We can just hide them. Now the software will hide everything but the closed surface. You can see that the color changed. That's standard on CATIA, this metal color. Now our frame is done. we can move on to the finite elements analysis right now. One thing that is very important to do when you're going to analyze your work is to add the material. It's very important to add the material because the material has all the properties that CATIA will use to create your analysis. You want to click over here on Apply Material. A bunch of materials will appear. We are going to move to the Metal tab. Select Steel. We want to apply material on the entire part. So here in the tree, you can select the entire part, apply material, okay. Now we are working with steel right now. You can change the way that you view your part in order to see the color of the material. You just select here, shading with material. Now you can see it got a steel color, very pretty. Now we can move on to the finite element analysis. You want to hit Start, Analysis and Simulation, Generative Structural Analysis. This box over here, leave it on Static Analysis, hit OK. Now, these over here will be the properties of the material. CATIA recognized that there is a part already here in our environment, which is our frame. So the software automatically creates the properties of the material. You can see here in the tree, property 1, materials 1. This is wrong because we are working with a hollow tube, so these properties are considering that this is solid elements, which is not. You want to right click, delete. You want also to delete the properties and the material. There you go. Now we are going to create the mesh, which will be used in the finite element analysis. We want to go here in the model manager. This tab will be here on the side. I just move it to the left so it will be easier for me. We are working with hollow elements, so we just want to analyze the surface. So you have to come over here on Octree Triangle Mesher. If this was if you want to consider inside the material, you have to use the tetrahedron. We don't want that. We want only the surface. So select Octree Triangle Mesher. We want to mesh the entire stuff. Since everything is connected, you can see that it's already selecting the entire product. Left click. This will be all the properties of the mesh. We want to choose linear. Hit OK. Now it created the mesh for us. You can see the mesh by right clicking on nodes and elements, mesh visualization. Hit OK. There we go. We have the mesh created. Alright. If the presence of the mesh is annoying you, you can just hide it. I don't like it. I prefer without the mesh. It's easier for me to see it. So just right click in the mesh, active, deactive. There we go. The mesh is still there. It's just not showing. Now we have to create the properties of our frame. For example, the thickness, because we are only work with a surface, but we did not define the thickness of our surface. You want to go here to the property. You want to select the entire part. So you have to open the link manager, open the part 1, and you will select the part body. There we go. Now we selected the entire body. Material, it's using steel, the way that we define it. Thickness will be 0.01 inches, that's good enough. Okay. There we go. Our frame is good enough to start the analysis. But first, we want to apply some forces to see how our frame will perform. I want to clamp one side of the frame. I want to clamp this side over here. Clamp will mean that this side will stay still. I want to select the entire surface, not just the point and not just the limitations. There we go. I'm selecting one face. You can see on supports. Nice. I want to apply a force in the other end. You can come over here. Distributed force. I want to apply a force on the negative z direction, which will mean that the force is going from up to down. I want to apply the force on the face again. You can see by the arrows the direction of the force. 200 pounds is good for me. Hit OK. Alright, so now we have our frame with the meshes, with the material properties, with the thickness, with the force, clamped. Material is good enough to start the analysis. You want to select the compute. Here you want to leave on all. This way everything will be analyzed. Hit OK. Select yes. There we go. CATIA already analyzed our elements. And now we can go to the post-processing phase, which means that we can now analyze how our frame will perform with the force, with the clamp, with this material, with everything. This image toolbar presents the three main features on CATIA. We can see the deformation, we can see the stress, we can see the displacement. For us here, the displacement is the most important, so just select displacement. It is showing by arrows. You can see here on the right side that each color has one displacement value. This is very hard to see, so you can double click, select average ISO. That's much better. You can see that the arrows are just fluctuating right now because this means that our frame curved. You can see how your frame performed after time, selecting the animate feature. Let me pause. I want more steps. This way the animation will be smoother. Play. Let me speed it up. As you can see, the side and the back became still because it's clamped, and over here our frame is coming down because of the force. You can also analyze the stress, you can analyze your deformation, you can apply gravity, you can apply temperature, you can apply whatever you want. That's it for this tutorial. Thank you all for watching. I hope you guys learned something useful.